Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the DIY metal milling machine known as the Green Machine. So we're going to take this particular day. We don't have anything extra to do on the water jet, as I'm still working with those guys to get the hose. They want a large amount of money for that hose. They want like about $400. So yeah, I think I'm going to get pretty close to that $2,000 all up for the machine. So I have about $100 for the valves to control the air pressure. Hosing for the air pressure is going to be relatively cheap. Just go to Harbor Freight and get that. And then just have a two-piece barb fitting that holds that brings the water in, and then somehow make some adapters to go into those holes. The 7/8. Maybe I can find a 7/8 18 barb fitting and just use the water line right up to that. That should be no problem. As long as it doesn't leak, just put a whole bunch of Teflon tape around that, not a problem. And then I need to talk to them tomorrow about that manifold that we designed in the last video. And then from there we'll be able to work forward. And maybe they'll be able to drop the price, because they want about $200 for the adapter. And so they want $200 for the adapter, about $400 for the hose. So that's like $600 for that side. Almost as much as the pump itself. And then we got $200 for the CNC machine part. Then we have the gerbil, which I already have. That's not a big issue. And step motors, well, step motors are going to come with it. So step motors are good. Brackets are good. All that stuff for the CNC is good. Then I need to do the low side, which is have the water there, and then put the, screw the hose up, and then that should be good. And then, yeah, we should be good to go for at least a test. And then they have, I think, a couple week lead time on the shoulder adapter. And then I'm going to talk to him about the manifold. And then also I need to find some 120 mesh, because if you go on the Protomax, the Protomax has a 9 thou orifice, and they have a 30 thou mixing tube, which is about 3 times, which is pretty normal. 3 times, so 9, 8, 27, so that's 3 thousandths over. To get the 30 thousandths in mine, I have the 6 thousandths 3 times. That is 18, and I have a 20 thou orifice, so we're about there. Obviously, I have a smaller jet by 3 thousandths of an inch, or basically like 30% or something. 9 divided by 6. That are 50%. It's 150% bigger than what I have. So what I'm going to run is, so they're running a 9 thou orifice, and they're running 80 mesh. And the 80 mesh has a particle size of 8 thousandths normally. Nominal size of 8 thousandths. So what I'm going to do is I'm going to drop down to the lowest that they usually run, which is 120 thou. So that is, sorry, 120 mesh, which is the very lowest for water jets. But that guy is, I believe, a 5 thou size. So, which again is 1 thou under my orifice size, which is the same as Protomax, which is 1 thou under orifice size. So we should be good to go. So we're right at the lowest and the finest grit that you could run, 120 grit. So we should get a very hairline cut with that small of an orifice, with a 6 thou orifice and a 20 thou mixing tube, which is 1.5 times smaller than their orifice. So we should get a good mix, but we definitely have to drop down to the 120 grit garnet, and 120 mesh garnet to get, because again, the bigger the grit, it's just going to be heavy in that how much energy is in that beam to accelerate is questionable. So we should get way better cut than Wazer and something comparable to the Protomax, hopefully. So we'll see, for about $2,000. So we'll see how well that works out. And then use this machine. So basically, we have this machine. We got to get the we got to get those two connections. And probably what I'll do for initial test is I'll wire everything up and I'll connect everything up. Flip on the compressor, start pumping some water out of a big bucket or something. Just stick a hose in a big bucket. And then I might have to work at priming it. So what I'll do is I won't do full pressure. I'll prime it at a low pressure and then start clicking up the pressure. So just kind of prime the pump at, like 5-6 pounds up the pressure slowly until I have it fully primed and then ready to rock and roll. So that should be how I plan on doing it. And then pretty much fire the laser, I guess you'd say. The laser made out of water across the street there or whatever. And then also another thing, that's one thing that we missed, is we need to do the garnet. So actually, the garnet hopper. So now that I think about it, let's do that in this video. So let's put the DIY metal mill on hold, and we're going to change this to the water jet video here. So we do need to make one more thing, which is the garnet, which has a hose at the bottom, and this is probably going to be 3D printed or made out of acrylic. Either one of the other. Another thing that I could do as well is just have the front piece be made out of acrylic or something, or with acrylic bolted on. That's way better than having it glued together. So just have acrylic on the inside bolted on, or it doesn't even need to be bolted because it's going to hold it in there with all the garnet. And then as the garnet goes down, it's got to go into a little filler, into a little hopper. And the hopper is going to be rectangular, but kind of funnel everything in with a taper, kind of like on the Fill Factory, which videos you'll see soon. So it funnels it down into a little funnel, and then a tiny little hose goes down and goes into the cutting head. So we have a kind of a set size, and that is the 2.5 inches because that's basically where the mill is going to be. So we want it to sit there because otherwise it could hit whatever material we're making. So let's go ahead and design that. So basically we're changing from the mill over back to the water jet because we do have one more thing to design before that. And then sometime next week we'll probably start going back on the making the mill. Again, because we're going to basically run out of water jet stuff until we could buy all of the parts and start assembly. So again, like I iterated, so $400 for the hose and then $200 for the adapter. I'm going to see if we can get these guys to do more of the stuff. For example, the high side, because really I don't want to do too much on the high side, because it's very important that that stuff seals up, so I might need to leave that to the professionals. So we'll see, because I'm pretty sure I could do it, because basically what you have there is it's just a little 118 degree going in there and touching it. So we'll see, and we'll see what they say about where they're opposing, because again, it was a T, so we have water going here, and then one going in. Maybe if he wants the out to be here, but then this is also perpendicular. So instead of them hitting parallel, they might be better hitting perpendicular. But the flow rate is way low, so I'm not too worried about them hitting really, really fast, because basically it's extremely low flow rate, but very, very high pressure, right? And then basically by the time it gets to the orifice, that's when it speeds up. So I'm running a very, very low feed rate, which I need to look back into again. But I'm running a very, very low feed rate, so the speed is not going to be that big of an issue. So probably even if they're parallel, should probably still just combine and go through the low pressure section and just kind of press through. So this is the last big component that needs to be designed and probably going to be 3D printed. Hopefully that 120 does not get stuck so much on the walls, so I'll probably have to do, and I do have this new printer that has the 12 by 12, right, the X5SA, which is what we're going to get similar for the body. So that's a 12 by 12 by 15 tall, so not a problem to make that. So let's go ahead and look at the body. So the body, we have 2.5 inches, which is not a lot, which is basically the height that we have with and this could be up to 12 inches. So basically what I'm saying is that we have a very, this is the mill. So the mill is 2.5 inches wide. Is going to be 2.5 inches wide because that's the plate I have access to. So this guy is going to be up high and then have this hose go down, very, very thin PTFE hose because I need it to be as flexible as possible. And that's probably going to be up against the wall and going to come down. Or I could have it elsewhere. Because again, basically there's a vacuum forming because the jet is going through the orifice and expanding into the chamber on the inside. Because it's going from high pressure to low pressure, when it goes through, it increases velocity as it goes through the orifice, and thus drops pressure, because pressure and velocity are inversely involved. I believe they're exponential. I can't remember, but I think it's with relation to 1.4 or something like that. So yeah, I'll have to look because it's what was that one? Bernoulli's principle, right? Or Bernoulli's equation that basically has that, which is along a streamline, one specific streamline. So as it goes into the cutting head, it expands, and when it expands, pressure drops, and when there's a pressure differential, there is it sucks in garnet from the top. The garnet falls in, and the garnet is fed past. And then also have a little locker thing also that I could use to kind of pinch off the garnet. Have a little a little piece that I could crimp on the garnet to lock the garnet off, and that should be fine. As you saw in that other one, he had on the very first video, he had the DIY water jet with a pressure washer, and he had the same deal. He just had this cylindrical, this circular acrylic. So that would probably even work as well, but making the funnel is a little harder. Right, the funnel at the same diameter, unless you're 3D printing it. So let's do something like this for right now, and then let's do offset inside, and let's do like 1/8 of an inch wall. And then also another thing that I'm interested in seeing is how much garnet we could exactly get in here. And then so this, we have to do 15 inches minus the bottom thing, so let's say 8 inches here. Let's do 9 inches. So there's 9 inches. And if we go here, actually no, let's do the funnel first. Okay, so what's the volume here? Properties, volume is 270 square inches. 270 inch cubed. Okay, so we'll see exactly how much we could do, and 9 inches isn't really a lot, so we'll see how much weight we could put in there. And we do have some sand, we do have some 120 grit, and because it's 120 grit, it'll fit. We put more mass in here, so it should be even better. Because the garnet size is smaller, so you get the particle sizes even closer together. All right, so then what we're going to do is let's do a loft. So then what we're going to do is an offset plane. And let's do an offset plane here. And I believe this is 9 inches. So let's go. and there's 13 inches. And again, we don't want to go too small of a tube. I would rather go a small thin wall tube because of the issue of it getting clogged. Wait, 325. I think 325 should be okay. And then offset, let's be 0.125. So now let's see if this freaks out. Probably gonna have to do the other way, but let's see. I always get this wrong here. Okay, the loft cannot be created. Try changing input swap profile. Yeah, because you can't do this because it's not a circle. And also, I don't want a whole lot of garnet to get stuck on the inside here. So maybe if I fillet the inside, modify fillet. I always struggle with loft. Loft is a very strange. Oops. Let's see if that helps a little bit. I wonder if it wants to be more solid. Maybe we should do that. And then I could go in and shell it. Let's try that. Let's see what happens. Modify. There we go. There we go. And then I could shell it. And then we go here, sketch. And then also we want that edge to be filleted. We want it to roll in there. I think that's way too much. It looks like okay. But the question is, does it show outside? And then, because generally you want to always, if you're not machining and it doesn't cause a whole lot of extra time, you always want to fillet stuff that are straight angles because it helps increase strength. because you don't have a lot of concentration of stress. That looks really good. Okay, then we need to do a hole in the front, basically for the acrylic to fit in there on the inside. So let's do a rectangle, center point, and then the idea is we're gonna just place a square piece of acrylic in here. Like so. And place it in there, like so. And then we're just gonna put a piece in here, and you can even glue it in there. I mean, it's gonna start, probably put a piece of clear plastic over the top of it, or shoot it with clear coat, or do something like that, so that we could keep, so it doesn't get so roughed up with the garnet as it goes over it. But eventually it will, and we're not gonna be able to see how much we have in there. But the idea is we want to make sure that this guy stays filled up, and then we could place a hopper in here, and we attach this to the wall with some fingers or something here, or screw it through the backside, or do something like that. So we could have it where there's 2 screws here, you screw it to the back wall. Okay, so now okay, so now let's look at 120 mesh garnet. So I do like this one website. I mean, it sells it by the ton, or I think that's actually metric ton. So I'm not too interested in that, but it gives density, grams per cubic centimeter. So we had it here, 270 inches cubed, grams per centimeter cubed. Centimeter cubed to inch cubed. So here, density, where'd it go? Right here. So here it's saying grams per centimeter cubed, so inch cubed is 270, 4,000 count, 4,424. Oops, hit the wrong button somewhere. $4,424.5 times 4.1. It's about 40 pounds. 40 pounds of garnet. Actually, pretty much exactly 40 pounds, plus the funnel, and plus what goes in the tube. Right? So I'm going to say easy 40 pounds, maybe 50 pounds. Let's see what Wazer has. Because again, we're similar to Wazer and Protomax. Let's see what they got here for Protomax. Also, I like the little cutting rubber thing. I would like to make that as well at some point. So So their hopper capacity is only 14 pounds for the Protomax. So I think we're in good shape with this. 14 pounds for Protomax and Wazer. Oh man, Wazer's come a long way. Website looks really good. Let's see. Have they upgraded the metal yet? 66 minutes for that part. Oh, 21 pounds. Holy crap. Oh, they're saying, okay, tool steel. Okay, so cutting 160. Okay, so now they're saying that you can cut 1/4 inch. Max thickness for this material. Low carbon. Stainless 120. Cut time 27 minutes. Cut time 85. Okay. Interesting. Cut speed 0.21 inches per minute. Oh my god. Wait, what is this? What the heck? It blew out all the corners. The straightness looks okay. 15 thou sheet metal. Wait, how did I do that before? There we go. 3 inches per minute for 15 thou. Yeah, this is pretty low. O1 tool steel. Cut cost $15. Cut time 85. Cut quality coarse fine. So they say fine, it probably is spending a really long time to cut that. So that's interesting. Because I think it's just so low pressure. Interesting. Okay, let's see if they're pump box size, box weight, cutting area 12 by 18. Okay, so it's bigger than the Protomax. 1/16 kerf. Okay, so water source, water filter, 100 mesh. Okay, so they have 40 pounds. So yeah, we're plus on Wazer. And Wazer's also using 80 mesh. Interesting. 1/2 inch marble. 8.2 pounds. Yeah, why does it always have this where it blew out the backside? Glass. Silicone rubber. HDPE, 1/2 inch HDPE. Whoa. Oh, it's doing a Mickey Mouse ear, I think, in that corner or something. This looks really good. The hole looks really good. That looks really good. Kerf looks pretty good. 1/2 inch, 0.6 inches per minute. Holy jeez, man! And again, remember ours for our material is 888 inches divided by 0.6. That's 1,480 minutes. It's about 24 hours of cutting. That would be really bad. So, let's see. Cool. Well, I'm glad they updated the website. So what about aluminum? So probably we'll be cutting as fast as their 1/4 inch aluminum, most likely, because we double our 1/4" aluminum. $3, that's what we're talking about, but still it's blowing out the corner. Kerf looks great. That looks pretty good. They're still cutting at almost 1 inch per minute. You know what? I think I might call Protomax or the Omax guys tomorrow and ask them what kind of speeds they're getting 1/4 inch low carbon steel, just to kind of find out. So 888 divided by 0.9. 16 hours, 16 and a half hours, using 7 pounds of garnet. So basically, and you have to replace it every 5 hours. Every 5 hours, you have to refill the tank. All right, so basically, I think that this is good. 40 pounds, that's looking good, and a little bit over here and a little bit over here. So I do like that a lot. So I think that we are in good shape. That looks really good. So gonna put this together, get a little piece of acrylic. I have a whole bunch of acrylic laying around, so just cut it to size at the shop and stick it in there and then glue it in there. Okay, so looks really good. Print it obviously with this flat, and then maybe make a cap for it, and then just use a funnel, regular funnel, pour that stuff in there. Alright, so that looks good. So now we have pretty much all the points, so I need to talk to Tim tomorrow about these manifolds and more about the prices and see if there's any sort of something that we can do with the price, lower it down just a little bit, maybe have them do a little bit more work for the same amount as they're doing with that hosing, and see what else we could put together. Alright, thank you guys so much for checking out this YouTube video. So I think we are good to go on pretty much all these parts here. Again, hosing here, but the thing that I want to do the quickest is I want to get the jet firing, get the pump working, and working here in the garage, pump 60 psi, and then look at the CFM that's required and how often my compressor cycles. And that will determine when I have to buy a new compressor to get all this stuff to work. So we'll be looking into that in the near future here. And then also it's going to be, because it's going to be about a month until I get the housing. I mean, because it's going to probably be slow boat from China. So to get the actual gantry to run the thing. So we're going to have to wait for that, but by that time I want to make sure that that the water jet fires, the garnet fires, and that we could actually, if I attach it, if I rigidly attach it to something and I build a tank, can I fire it and cut through something? And does controlling that those two pieces, does that actually work? If I could flip a switch, you know, a 12-volt power supply, if I flip the switch, how fast will it cut the pump, right? So that's what I want to check and make sure that everything like that works, and order all the valves and order all that stuff. And so that will probably be ordered at the same time I order the hosing. So I'm going to double check on all that stuff and figure out, then we have to look for the 7/8 barb, which actually I should probably wait even longer on going back to the mill, because we also have to do that. We have to look for all those barb fittings and everything that we're going to put inside the pump. So hopefully tomorrow, my boss is leaving a little early, so hopefully I can go back to the shop and pick up the pump, so we could do the actual measurements for the manifold and find some barb fittings to stick in there and some hosing. Alright, so then also I'm working in parallel to get some of these shredders made, so I have some time to test all this stuff. And again, it's not going to cost a whole bunch per shredder to get it done elsewhere, so not that big of an issue. Yeah, so this has been Steven from Legit Tech Tutorials and Green Engineers. I'd like to thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys in the next video. Take it easy. Peace.